Okay, so sample exam 5, 1 through 14, number 5. First one, we got from 0 to 8, 1 over the cube root of 8 minus x dx. Alright, and this is a situation where, again, we have, ultimately it's an improper integral because the 8 in here would give us 0 on the bottom. Okay. So if we set up our limit as b approaches 8 from the left, 0 to b, 1 over cube root of 8 minus x dx, and we can go from there. And ultimately, if we use our u substitution here, we ultimately have 1 over cube root of u, if you will. If we let u equal 8 minus x, and our du then would be just negative dx. So negative du we could use to replace dx. And that means our substituted integral would become, in ours right in power form, would be u to the negative 1/3. And then negative du, or negative out in front. And then from there, if we integrate, we add 1 to negative 1/3, we get u to the 2/3 over 2/3, so it'll be 3/2 here. And ultimately we'd get u to the 2/3 here, 2, 0 and b. Actually, I'll put my 8 minus x in there first. Sorry. I have to be on that step. So my 8 minus x is in my parentheses now. And if I put a b in there, I'm going to get the opposite of 3 times 8 minus b to the 2/3 all over 2. And 3, 8 minus 0 to the 2/3 all over 2. And with that, let's see what we can do here. And keep in mind we're taking the limit here as b approaches 8. So if we let b approach 8 here, we'd have 8 minus 8 on top, which would ultimately be 0. Okay, so we do get a finite answer there. We get 0 this time. And if we do the 8 here, if we do 8 to the 2/3, and 8 to the 2/3 is just the cube root of 8, which is 2. Square that, we get 4. So the parentheses here, we have 4 times 3, that's 12. Divided by 2, that's 6. So we get minus 6, and then ultimately we get negative negative, give us a positive 6. And therefore we should have that correspond to C. So again, even though there isn't a value at 8, okay, we can sometimes still find a finite answer for an integral that's an improper integral, one that has a discontinuity or whatever the case may be. And ultimately that would be, I mean the substitution part of that is obviously AB, but it's essentially it's a BC problem because it's an improper integral. Questions on that one? What else, 1 through 5? Six, 10? And 6, we have integral of x sine x dx, which ultimately is not a known derivative. Substitution doesn't do us any good. It's product though, so we should think integration by parts probably, since x is easily differentiable and sine x is easily integrable. So if we let our u equal x and our dv equal sine x dx, our du then would be dx, and our v would be negative cosine x. The antiderivative of dv would give us that v. And then our integration by parts setup is uv. If we do uv, we have negative x cosine x off front, and then the integral v du. So, again, our uv out in front, negative x cosine x, minus the integral of v du, would be negative cosine x dx, and such. Which ultimately the negative can come out. Negative cosine x plus the integral of cosine x dx. And with that, the antiderivative of cosine x, of course, is sine x. Since it's indefinite, plus c on the end. Which would correspond here with, looks like d. And that's ultimately a BC problem because it's integration by parts. Keeping in mind that, remember too, on a multiple choice test, is there anything stopping you from integrating all 5 choices and seeing which one gets you the integrand? Or differentiating, I should say. Can you differentiate the 5 choices and see which one gives you the integrand? So, probably easier to just do one integration by parts than it would be to differentiate all 5 of those answers and hope that it's not C, right? Or E, I mean. What else? 6 through 10. Ian?
8.
Let's see, number 8. We have sine x y equals x squared, and we want to know the derivative. So the derivative here, recognize that it's an implicit differentiation problem. So if we implicitly differentiate here with respect to x, the chain rule issue here is that we'd have cosine xy, that is, times the derivative of xy, which is a product, so we'd have to go x dy dx plus y. And then over here we'd have 2x. And from there, we distribute, get x cosine xy, dy dx, plus y cosine xy. And subtract. That. And then finally we can divide, get our dy dx. So 2x minus y cosine xy over x cosine xy. And all we were after here was the derivative, right? Okay. So if you look at the options that we have there, what do we see? Doesn't look like any of those, does it? Okay. So ultimately the issue then is can we manipulate any of our expressions here and get it to look like any of these that we have? What did you say here? What if we split this up first? What if we did 2x and then x cosine xy minus y cosine xy over x cosine xy? What if we did that first? That would be a valid move, wouldn't it? Basically just be unsubtracting those two, if you will. We could have a common denominator and take those apart from their addition. Okay, ultimately, what would that do for this? Those two would be gone, wouldn't they? And then what would this become? Instead of cosine xy on the bottom, I could rewrite that as secant y on the top. And keep in mind these x's would be gone. So I'd have 2 secant xy here. And then over here I'd have y over x. And if you look, still don't have that per se, that exact expression. True? So ultimately though, if we were to get a common denominator here, would it be 2x secant xy minus y all over x, which would be letter E. So again, when people ask, are there pre-calc problems on the AP test? The answer in general is no, there's not pre-calc problems, but are they able to test whether you can do any pre-calc or not by putting a problem like that on there? Definitely. Okay. You need to be able to manipulate expressions, and especially in the multiple choice part. You know, we had the right answer at this point right here, but ultimately that's not in the form they were after, right? So we just gotta finagle it and see if we can get it to be in the right form by using our simplifying techniques, either trigonometry or otherwise, but bottom line is we used some algebra to get it into a different form. Hopefully match up with the correct answer. this will be an AB problem, just implicit differentiation. Questions? How about others? 6 to 10. Jake? 9. And 9, it says we have some tables here given. And this is for all x in the closed interval 1 to 4. This is the function g is concave down. And it says which of the following could be table or could be the values of g of x. So keeping in mind that we have a closed interval. G is concave down, which means the second derivative should be negative. Oh, yeah, it does say up. Okay, the u word is up, not down. All right, so ultimately it's concave up then, as we see. And question is, which of the following tables could be the table for g of x? So looking at the tables that we have, what do we notice about, if we just start with A, for instance, looks like as we go to the right, the values are getting bigger or smaller? Going from -10 to -2, that's not smaller, is it? Yeah, they're getting bigger, aren't they? Okay. And so if we take that one, for instance, they're getting bigger. And keep in mind that concavity doesn't have to do with increasing or decreasing. It could be concave up and decreasing. True? Like this, for instance. That would be concave up and decreasing, wouldn't it? So that could be the case. It doesn't have to be increasing or decreasing. It doesn't really matter. Okay, so it could be any of these in terms of whether we're going up or down. And you'll notice that all of these were going up except for, what, letter D? Well, I guess not E either. Okay. That'd be a combination. But again, starting with choice A, if we look at the points in question here, again, our interval is always uniform here. We're going from -10, then to 7, then to 6, and then to 2. And so ultimately, again, if you kind of plot these points, we get a fairly decent general idea of whether or not we have a certain concavity. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we're at 1, 10, and then we're at 2, -7. We're at 3, -6. And just drawing that point right there would probably indicate that we can be done at this point, true? If I were to draw those with a smooth curve, would that be concave up? No. So I think that A is out here. The next one, we got 1, 4. We got 2, 6. 3, 9. We got 4, 14. 4, 14. Notice that these are going up by 1 more each time. The first one went up by 2, then by 3, then by 4. 3 more. Okay. Ultimately, wouldn't that be the one? Wouldn't that have to be concave up if we had that behavior? Okay. And if you check the other ones, you can see that the part C goes up by 5, and then by 7, then by 2, and then by 5 again. Okay. Ultimately, if we did 1, 0, if you will, and then go up by 5, and then go up by 2, and then go up by 5 again, wouldn't that pattern of points essentially have both concavities probably? We went up by 5, then by 2, then by 5 again. Okay. What do you notice about part D? What's part D's deal? Goes down 2 every time. Isn't that just a line? So if that's a line, then there is no concave up or down. And then the last one, again, we're going, that one goes from -2 to -1. It goes up 1, then up 4, then down 2. Okay. If it goes up and then down in any capacity, isn't it going to have some kind of shape like that? And so ultimately we could rule out the others, or we could rule in B by recognizing that as we grow, if we're going faster each point that we go to the right, it's going to create a concave up situation, and therefore go with letter B. So ultimately, I guess I'd classify that as a AB problem. Just derivative and second derivative shifts, concavity, increasing, decreasing, and so on. What else? Okay. And number 10, we got another integral to do here. It's x squared plus 4x. And it's not a known derivative. And if it's not a known derivative, then the next step would be substitution. But if we substitute, we'd have 2x plus 4 as our du, which ultimately there is no 2x plus 4 there to get rid of, so that's not going to work. So ultimately, if we recognize that it's a factorable denominator, we should hopefully think of partial fractions. So if we factor x and x plus 4, and we do our a and our b, and separate that denominator, figure out what the tops would be in order to get back to what we started with. The procedure, again, is to, if we multiply the a by the x plus 4, that would give us the common denominator, and the top would be corresponding, it would be x. And we know all that needs to equal 1 because the original top is 1. And if we write ax plus bx plus 4a equals 1, that means that a plus b times x plus 4a equal 1. And with that, a plus b would have to equal 0, and 4a would have to equal 1. Means that a would equal a quarter. No, not 4, but a quarter. And if a equals a quarter, then b would equal negative quarter. So with that, we go back up to our original here. We have a quarter over x plus a quarter minus a quarter, that is, over x plus 4. And so with that, keeping in mind that 1/4 divided by x is the same as 1 over 4x minus 1 over 4 times x plus 4. And again, as soon as we write it in that form, then we can write them as integrals. And they did it separate in the multiple choice. And if we look at the choices that we have, looks like it's got a minus sign, should be letter E. Select the correct one. And ultimately this is a BC problem because it is partial fractions. Anything else 6 through 10? Last part, 11 through 14. And 12 here, it says what's the 20th derivative of y equals sine 2x. So we got a couple options here. Number one option would be that we could actually go ahead and find 20 derivatives here. Okay. Or we could ultimately, we know this is going to be some kind of pattern here because we know it just switches back and forth between sine and cosine, positive and negative, and so on. So ultimately, if we did y prime, we'd get 2 cosine 2x. Y double prime would be 4, negative 4 that is, sine 2x. Y triple prime would be negative 8 cosine 2x. And then y 4 would be 16 sine 2x. Alright, and once we get to that pattern, then ultimately we're going to go back to cosine 2x, sine 2x negative, cosine x negative, back to that, so on. And ultimately, the issue then is what's it going to be at the 20th derivative? Well, every fourth one, okay, this one's going to occur again at the 8th, and the 12th, and the 16th, and the 20th, isn't it? Key issue though is that if that part is all well and good, you can rule out some of these in here. You can really only rule out, I guess you can rule out C, D, and E, which is convenient. But the issue is it going to be A, B, or A or B? Well, I guess you could probably rule out A also because of the fact that it's negative out in front. How about that 2 to the 20th part there, though? Notice that the pattern here of numbers out in front, we're multiplying by 2 every time we do this. 2 to the 1, 2 to the 2, 2 to the 3, 2 to the 4. Doesn't the power on that correspond with the derivative number? So should it be surprising that we have 2 to the 20th here when we get all said and done? And ultimately that would be a AB problem. Just find your derivative. Trig functions. Try to find that pattern. Like I said, you could carry it down all the way down to 20 derivatives if you'd like to, but ultimately you can hopefully generalize after you get to the fourth one. What else? 1 through 14. Number 11, we have a picture of a graph on the interval 1 to 4. Notice it's closed interval. And it says of the following, which has the least value. And so in our graph that we're given, the first part A here is asked for the area from 1 to 4 of f of x dx. And so ultimately we want to see if we can come up with a value for that. Now remember, we don't have an actual rule for this function, so there's really no way we can evaluate that integral directly. Okay, we can see though that the area under that curve being a positive valued function, that we know that the answer at least is positive. We could say that much. True? All the area under there is positive. All right. Now, part B says, how about the left Riemann sum with 3 subdivisions of equal length? So if we did a left Riemann sum, and again keep in mind that our picture is an increasing and concave up function, which is important. If we did left Riemann sum here, we would get rectangles that look like that, wouldn't we? And ultimately, how would that compare to the actual area under the curve, which we have in part A? So who wins out of A or B? Who's bigger? A is bigger. If we did a right Riemann sum, we are going to use, again, 3 subdivisions of equal length. If we were to draw the right Riemann sum for a curve like that, remember what we draw is we draw that, and then that, and then that, approximately. That'll be our rough picture of our right Riemann sum. And if it's right Riemann sum, then ultimately, again, who wins? Right or actual? Oh, the least? Oh, my bad. All right. So the least one, I guess, now I guess we're B is clearly the winner out of all 3 of these so far in terms of least. Right? Okay. And then if we do midpoint, remember both midpoint and trapezoid and DE are going to give us an area that's much closer to the actual area than either the left or the right. True? So ultimately, which one of these is going to give the least? It would have to be the left Riemann sum, wouldn't it? Circumscribed rectangles. And ultimately, the key issue is that it's an increasing function. So again, key issue with that is that it's an increasing function. So if it's increasing, then LRM is always going to give us an underestimate. IRM is always going to give us a overestimate. And the trapezoid and midpoint. In this case, the trapezoid would be an overestimate also, remember, because it's concave up. Remember, trapezoid rule has to do with concavity. So if it's concave up, the trapezoids would be over the curve. If they were concave down, the trapezoids would have been an underestimate. So in this case, they're an over. The midpoints would be somewhere in the middle of left and right, obviously less than, or more than left and less than right. All right. What else? AB problem. Anything else 1 through 14?